For those of you who are joining our little series here for the first time, my name is Henri Schulte. I work as a partner solution architect at Microsoft Denmark. And here I work with our local partners when it comes to building AI into their applications and into their solutions. And for the past few years, now 2 years roughly, this has primarily been generative AI, because let's be honest, that is what's really the most exciting right now. But it's not just exciting, it's also really changing things. You have probably seen every conference right now has an AI track. Every newspaper has articles about AI pretty much daily now. It's very hyped. Of course it is. But it is not hyped without reason. It is actually changing things. It's changing how users are interacting with software. It's changing how businesses and organizations like CluedIn are building software as well. So that's what I want to spend a little bit of time here today on, is just to talk a little bit about how do we do this, but how do we do this the right way? How do we build with generative AI in a way that's responsible, not just from a perspective of privacy and ethics, but more so from a perspective of building AI systems that actually work. Before we get too much into this, I just want to take a step back and talk about the way we as humans interact with computers. If you've seen me talk about this topic before, you might have seen that I love calling generative AI a new milestone in the interaction of humans and computers. Because if you think back to the very beginnings, when computers looked like this, you know that it wasn't quite easy. It wasn't easy necessarily to work with command line interfaces with the computers of the day. You had to know exactly how to operate them. And even with the next step of human-computer interaction, the next milestone, the development of the mouse that brought along the graphical interfaces, still needed us as users, as humans, to know how to operate them. Of course, it was easier now. We could see what we're doing and we could move windows around, but we still had to know exactly what buttons to click in what order to find a specific setting somewhere deep in the bowels of Windows 95 or so. And not much has changed since then, right? If you look at your Windows 10, your Windows 11 computer today, you'll see that they look very similar. The corners are a little more round, but the rest of the interface is pretty much the same. And then suddenly, last year, when ChatGPT launched, people got to see a different type of interface. They got to see a natural language interface. Suddenly there was just a text bar, and you could just type anything into it and things would happen, or at least you would get some kind of response. And this is great, right? In some ways, this is great because for the first time in the history of human-computer interaction, users don't have to know how to operate the system. They just say what they need and they get some kind of response in return. But there's an issue with that. And the big issue with how many people in especially the early days of generative AI were using the system is that this really looks like a search bar, right? But as everybody who's tried ChatGPT and tried putting in a question knows, this is not a search engine. ChatGPT and other large language models by themselves are not search engines. So for example, if I asked yesterday here, is CluedIn integrating with Azure OpenAI? The model will say, as of my last knowledge update in September 2021, there was no public information or news regarding CluedIn and Azure OpenAI. Now, if you're following Tim on LinkedIn or you're following CluedIn, then you know very much there's a lot of public information on this. It's just not in the training data of the model. And this is a great example of why we cannot rely on large language models to hold any sort of relevant information, especially not current one. But this is exactly what happens when we work with large language models on their own. Alone, they're not very useful. So what can we do to change that? if you're working with large language models, or maybe even you are building systems with large language models in them, what can we do to avoid situations in which we get hallucinations, in which we get facts that the language model just makes up that aren't actually factual? I want to give you an example. Let's start with this guy. Many of you will remember good old Clippy and the more or less helpful pop-up around helping you to write a letter. It looks like you're writing a letter. Would you like help? That's the pop-up you would get in Microsoft Word. The problem is not a lot of people actually got help from Clippy. Of course, Clippy was very reliable, would give you the same tips every time, but they were very generic. It was the same generic tips every single time. They weren't actually helping you to write a letter, but at least they were always reliable. There were no big surprises. It was just letter writing tips every single time. Now, today you could say, well, why don't we just ask ChatGPT? You can do that. Of course, you can ask a large language model for tips for writing a letter, and you will always get some new responses. You could get a new tip every single time, potentially. And more importantly, you can prompt the model for custom tips. Why ask for tips for writing a letter generically if you could ask for tips for writing a letter to the municipality to complain about X, right? That's suddenly much more specific, much more useful all of a sudden. The problem is, asking a large language model, you have absolutely no guarantee for accuracy in this scenario. How do you know that these tips for writing a letter are actually good tips? Large language models are trained on all kinds of language. And if someone published a website on bad tips for writing a letter, that might be in the training data set too. Although, to be fair, we did ask for good tips for writing a letter in our prompt. Regardless, we have no idea where these tips come from. So we need some kind of way to guarantee the accuracy. So how do we do this? How do we combine the accuracy and the reliability of traditional software systems with the flexibility and customization or customizability of generative AI? That is the big question. And that is really the question that has kept us busy, us in the AI world for the past few months. The first, ChatGPT was the big moment that put generative AI out there into the hands of every single person. But then we had to kind of reel it back and then make sure that AI apps are also good and are reliable. The way to do that, to make it quite simple, is to use a pattern called Retrieval Augmented Generation. We'll get into that with an example here. Let's say we have an interface and some kind of backend code. I call it the Orchestrator here. And this alone could be our Clippy. We just have some code and that surfaces some information to a user. Now, if we wanted to turn this into our basic example with a large language model, we can just connect our backend code to the large language model. And when the user asks for tips for writing a letter, the orchestrator will query the large language model for tips for writing a letter. And the result of that large language model will be returned to the user. But then we're still in the problem of, we're just relying on the large language model to know any good tips. And not every question is as generic as that one. So what can we do if we want to be in charge of the data on which the large language model operates? We can connect the orchestrator not just to a large language model, but also to a data source. Maybe we have a whole number of files. Maybe we have PDFs somewhere that provide good guidelines for writing letters. Maybe we have a company communication policy that tells us how to write public statements. Maybe there is a database somewhere that collects some kind of information that we want to query. In this scenario now, the user asks a question, what are good tips for writing a letter? And before sending that to the large language model, the orchestrator will first check with the data source. Do we have any tips for writing a letter? Okay, let's get them and send them together with the question to the large language model to compose an answer. This way, what we're getting back from the large language model and ultimately surfacing to the user is actually just our own data, but composed by the large language model. It's not made up by the large language model. We can verify that this is reliable. We can trace it back to its original source. And we can take it a step further. Let's say we're writing a letter inside of Outlook or inside of Word or inside of any other kind of application. Let's connect the application as well. Let's connect the application to the orchestrator so that when the result comes back, we can also hook into an application and automatically surface it in Word, in Outlook, etc. Perhaps we want to write a letter based on this particular case from Dynamics or this particular customer account in our CRM system. All of this we can do by orchestrating it through our orchestrator in the middle. It's not the large language model that does all of this. The large language model can create plans. It can detect what the user wants to do and recommend which data sources to reach out to. But really, when it comes to the actual data, that comes from our trusted sources, rather than from the large language model. That's what Retrieval Augmented Generation, or RAG, is all about. Because the generation of the large language model, the generative aspect, is underpinned by data that we retrieve. And retrieval is usually the first step before any generation actually takes place. A great example of this is the Bing chat. If you haven't been trying out the Bing chat, I would highly recommend just giving it a little try. It's essentially like ChatGPT with a search engine. So if I ask a question in Bing chat, like what are the top announcements from Microsoft Build this year? This is not an answer, or this is not a question that the large language model underneath can just answer. It doesn't have that information in its training data. So you will see in the top, the first thing it does is it's searching for top announcements from Microsoft Build. And since this is Bing chat, it does a web search over the public internet and collects answers as if I were to type it into a search engine myself. This doesn't have to be the public internet. We could be searching our internal file store. We could be searching emails. We could be searching a SQL database. Any kind of data store goes. In this particular example, it's Bing search. And then you can see the next little item there with the tick mark. It says generating answers for you. This is where then the results from the search plus my question are being sent to the large language model to actually generate the answer. This is fantastic because not only do I get a generated response back that exactly answers what I asked, I also get references to where that information comes from. You can see down in the very bottom, it says this is from Windows Central and from Gadgets Now, but you can also see the little footnotes after every single item. So I can trace back this piece of information to a particular article on the web. And I, as a user, am empowered to say, this is what I want to trust, or this is what I want to double check. I would like to read the full article. I can do that. The pattern of retrieval augmented generation makes this possible. Think about it this way. If I want to find out what's for lunch, and I do indeed want to find out what's for lunch, in Denmark right now it's lunchtime, I could ask the large language model, what's for lunch today? But there is a near zero chance that the large language model will guess it correctly, because that's all it would do, right? It would guess what could be potentially for lunch. But compare that to asking this. I could say, answer the user's question, only respond based on the context provided. So far, so good. Then I give the question, what's for lunch today? And then I provide some context. And this is what we would get back from our retrieval step. Something like, today is Friday, the lunch menu this week is as follows, yada, yada. This is the lunch menu. With near certainty, A large language model would be able to determine today lunch is hot dogs. And today, it says today is Friday. Of course, today is not Friday, but you get the gist. And if you're looking at all of the copilots that Microsoft is building right now, the copilot in Windows, the M365 copilot, any of these copilots, the Bing chat as well, they are just examples of retrieval augmented generation in practice. And every organization can build these copilots as well. Your organization can do as well. CluedIn does too. You can do that because the foundational models, they're already there. You can use GPT-3 and you can use GPT-4 on Azure. You don't have to do any big data science project to train a new language model. And the way you differentiate is through the data you're providing and the prompts you're using to ask the model. Now, of course, we're talking a lot about Azure OpenAI here. We're talking a lot about language models, but foundation models are available in all kinds of different domains: speech to text, text to speech, vision, object recognition, etc. And what's most important is that we can do all of this while preserving privacy. If you're using the AI models on Microsoft Azure, then your data is your data. Your data is not being used to train the next GPT model, for example, neither by OpenAI, nor by Microsoft, nor by anyone else. And your data and the models you train with that data are not available to anyone either. That's very important to keep in mind. And that's also important to keep in mind when you're looking at companies like CluedIn, who are working with Azure OpenAI on building services for their customers. They can guarantee the very same. With that said, I think I'm out of time for my little section, so it's time we'll get back to the most interesting bit of the webinar today, and that's to see some of that actually in action. Back to you, Tim.
Thanks, Henri, and genuinely a really good setup, because what we've just talked about there is kind of, I guess, you could take that in this is the theory, and I think what Henri are doing together today is showing the theory and the practice coming together. So let's talk through a couple of slides before we dive in. So I think it's important to set some context. Obviously, Azure OpenAI, we're all aware of. We're now aware of the differences between OpenAI and Azure OpenAI, and it's really that sovereignty piece, the privacy piece, the trust that comes with Microsoft, and that's why we bet on Azure OpenAI. But from the CluedIn perspective, CluedIn is a Azure native solution for master data management and data quality. What does this mean? It really comes down to the data that we all have in our business. We need to make sure it's of high quality and high integrity. So as we start to use it out in the different edges of the business for business intelligence or machine learning, or eventually building our own co-pilots that learn and understand the knowledge that we've built up at our business over years and years, we need to make sure that we're driving these with high quality governed data. And one of the analogies I like to use, and this is more, I guess, for the IT audience that I'm talking to now, is MDM is quite an old category. It's about a 30-year-old category. And a good way of thinking about CluedIn and what it brings to the MDM space is very similar to what we saw in the data warehousing space recently. There has obviously been a modernization there, where now there's discussions of, do we want a warehouse or do we want a lakehouse approach? And each of them have their own pros and cons. It doesn't mean that one is worse than the other. It just means that, the lakehouse approach is really fighting for agility and flexibility and cloud nativeness. And the data warehouse is more about upfront planning, upfront modeling of data, a little bit more focused on getting data into a consolidated, predefined model. And the theory is there that after that case, it should be easy to proliferate the data out if it's in this standard format. And I think one of the ways to think about CluedIn is it's really the kind of the lake house of the MDM world. It's so much more focused on the cloud nativeness, the agility and the flexibility to change as your business changes as well, but still holding those core principles of we are here to clean data, we are here to make data ready for insight. And of course, the big topic today will be our OpenAI layer. So let's dive in. So another way to think about this is that at CluedIn and Microsoft, we see the importance of bringing in a different type of persona into the supply chain of data. And I think if you think about all the technology stacks we're putting together, maybe for yourselves, maybe for your clients, maybe for your own company, a lot of those different pillars we're putting in of technology, they are very much buried in IT and engineering. And this is for very good reason, right? Integration pipelines, lake houses, data science, all of these are inherently needing to be implemented and operated by IT. They are still extremely important. But we often have to ask ourselves the question, where do the domain experts of our data play a role on the supply chain? And I don't just want them as just consumers of the data, of something that gets kind of curated and spat out of the data pipelines from IT and engineering. I want them to actually have some type of say in the delivery pipeline of data out to the edge of the business. And for this reason, CluedIn has a big focus on putting the business users, the domain experts that aren't engineers, they aren't scripters, putting them at the kind of center, and of course, enabling them with a powerful language, a powerful engine in Azure OpenAI to help them do the types of day-to-day challenges they need to be involved in, while all still holding the core essence of what you would want from an MDM and a data quality solution. Things like matching and merging, stewarding of data, enrichment, workflow processes, still holding that to the heart, but delivering it in a much more flexible and agile way. Now, we were lucky enough through our Microsoft partnership to have very early access to Azure OpenAI. And this has put us in a position where we've actually been able to have our customers running in production with Azure OpenAI for many months now. And you can imagine this has been a very iterative and a high learning rate that we've been going through to kind of make the experience better and better and more reliable over time. And what we're going to show off today is the new AI assistant, this kind of co-pilot experience that really kind of acts like your buddy as you're going through some of these management tasks. As Henri alluded to, Azure OpenAI is obviously a powerful thing to integrate with, but it's also important that we meet Azure OpenAI somewhere in the middle. What are we bringing back to that story? And there's two main things that we always focus on here. One is the fact that there's often a lot of good deterministic functionality that exists in a platform. In our case, it would be things like business rules, enrichment from online services, building survivorship rules, setting up validation and policies. These are all typically very deterministic things. And when we're dealing with the models, they're often heuristic in nature. And how can we bridge those two to offer a seamless experience of running these tasks using the co-pilot? The other thing Henri already touched on, which is context, and that's probably the most important part, in that it's one thing to ask what's for lunch today, but without that context, we can't provide and get that nuanced answer that we're wanting. And you can imagine if we're in a MDM data quality, data management use case, asking, hey, tell me about this particular record. Well, you can imagine there's so much context that it knows about the metadata on it, when those records were received, the history of that data, and all this can be prescribed to provide a better prompt in the end to the large language model. And what this ends in is an amazing experience on Microsoft Azure. So CluedIn integrates with over 26 of the native Microsoft services like Microsoft Purview, Synapse, Databricks, Data Factory, Power BI, the Power Platform, and of course, now a layer of Azure OpenAI across the entire stack. So let's dive into the meat. So first of all, I want to take you through kind of a journey of how we built this experience that we're just about to show, and the iteration that we went through to get to a reliable AI assistant experience. And the first thing that we started with is something we actually borrowed from Microsoft themselves, which is to establish these kind of core ethics or rules or morals or code of conduct for what is our Copilot AI assistant experience going to be like. And I'm not going to list all of these off. I'm going to highlight two of them. And the first is make sure that we're not just using AI for AI's sake. It needs to add real value to the experience instead of just being something that, maybe is interesting tech. We really want to focus on an experience that saves money, time, heartache, cognitive load. The other core principle I'll highlight is what we share with Microsoft, is that your data is your data. In that none of the data that we type into our Copilot is ever stored, it's not persisted, it doesn't train an underlying CluedIn model. There is an interesting architecture that we have that allows that basically not to happen, but it's so interesting looking at Henri's notes, because we ended up going with a very similar architecture with the Orchestrator. In fact, we called it the exact same thing to get to the experience that we have to show off today. So before we dive in, let's talk through the kind of path that we went on. So as many of you might know, Microsoft have released a library called Semantic Kernel, and this has been out for some time, and it's very much seen as an SDK for players like ourselves, partners, to be able to build a Copilot experience into our own applications. Now, there are 100 good reasons to use this as an accelerator. And we'll touch on a little bit why we decided not to use Semantic Kernel for our experience. There's also the AutoGen. This is another library that's recently been released by Microsoft that's focusing a little bit more on the agent part of a Copilot experience. Instead of the request response of you talking to a large language model directly, what if that large language model orchestrated off to other agents to go and do some work? Once again, we have not decided to build our Copilot experience on this, but there are 100 good reasons of why you should look at that library as an accelerator. So the reason why we went with our approach, there's a little bit of history here. So at CluedIn in the early days, we spent a lot of our time building integrations to connectors like Dropbox and Dynamics and Salesforce and Navision and Trello and all of these different services. And a lot of these services, they had SDKs. They had SDKs that they really were at the start accelerators to connect, authenticate, and start pulling data from this. But what we found over time is they're a little bit hard to maintain. And the reason was because I guess we were always at the behest of when is that vendor going to upgrade their SDK because we found a bug or they're not covering all of their endpoints. And often when you have to fork these libraries, you have to maintain it yourself. So these were some of the reasons why we thought, you know what, going into this AI assistant Copilot experience, we want to be in full control, and we want to be talking directly to the Azure OpenAI REST service, which is ubiquitous, wrapped up in a nice bow, and has all the parameters we need to be able to do what's necessary. So you can imagine the first experience that we brought in was this kind of direct human to Azure OpenAI experience. And you'd be familiar with this with ChatGPT or whatever large language model you're using. You have a request and you get a response, right? What we found really quickly was that it was missing the interaction of, to Henri's point, knowing about the CluedIn application itself. And so we then went and tried something different, which was, instead of having a chat experience, why don't we just put buttons everywhere without the application and put static prompts in a way that maybe you could even inject configuration or variables. And it kind of has this hard-coded prompt like, hey, clean this data or standardize this field. And these are things that I would want to say to a Copilot anyway. It turned out this was a really good idea, but we missed this experience of having a buddy, of having someone join you and hold your hand through some of these cases. And this is uncanny, but what we ended up to get to our most reliable architecture, and to the audience, this was for us our quantum leap moment, where we went from an experience where we thought, it's okay, it's not bad, to an experience was, I can't stop using this thing. And it was this architecture we call human server orchestrator. And you can think of these as 3 different actors. And the human in this case would be me. The server would be the CluedIn application. And the orchestrator is Azure OpenAI. And instead of a human just talking directly to the orchestrator, there would be a prompt that would come from a human. And there would be, for lack of better words, a conversation that could happen between the orchestrator to the server, back to the human, back to the server, back to the orchestrator, back to the server, back to the orchestrator, because they're trying to essentially try out these different combinations of things. And a good example would be if we said, hey, I'd like to standardize all of the phone numbers I have in my data. It would go off and talk to Azure OpenAI. Azure OpenAI would come back with a structure that we would expect, but then it would talk to the server and say, hey, did I return the structure in a valid format? And the server might say something like, oh, you're not allowed special characters in the name. And so it would hand it back to the Azure OpenAI, which would say, okay, not a worry, let me try again. It would come back now with the cleansed name, it would try again, and there'd be this real conversation that would happen. This could also involve looping the human back. So if there's enough bouncing and ping pong that happens between the orchestrator and the server, we might go back to the human and say, I need a little bit of extra information. Here's where I'm currently at. Can you guide me through these final steps? And that's the experience that we ended up with that we're showing today, which I think you'll agree is pretty good. There are other ways that we've increased the flexibility and scalability of the architecture. So what we've also done is, instead of having one co-pilot, we actually have what we call sub-co-pilots. And these co-pilots are each specifically system prompted to only answer to a part of the application. That might be building rules, or it might be setting up survivorship rules, it might be sharing data, it might be mapping data. And the orchestrator is essentially responsible for handing this off to the right sub-co-pilot, instead of trying to be this generic know-it-all. And without this, it often led to experiences where it didn't exactly do the thing that we were after. And of course, watch this space, because this is the type of system where spending more time with it, iterating more examples is going to be the way to improve the quality. So for part 2, I'd like to focus on how the Copilot experience has now changed the way that MDM and data quality will work. And one way to see this is from my own personal experience. I never want to go back to a non-Copilot world now. And I've been spending the last few months with the CluedIn AI Assistant, and it really feels like when it's not there, you miss it. You miss it as this thing to ask questions to banter with, to help you facilitate tasks. And of course, the Copilot is CluedIn aware. So in Henri's slide, where he mentioned the orchestrator talks to applications like Office 365, this large language model, due to that actor architecture, is 100% aware of when does it need to involve CluedIn, versus when are you just asking for general information that the large language model can answer. The other thing is that it brings a lot of knowledge with it. And I know Henri talked about, don't use this as a fact database, and that's 100% true. But you can't help but realize that it knows about ISO standards, it knows about RFC standards, it knows about IEEE standards, and these are all things that you need to know if we're wanting to standardize and normalize data. Not to mention, it's great having general knowledge inside the application that you're working with. So before we go into the demonstrations, and that's probably in about 2 or 3 minutes, a good way to think about why AI is so important for the data management space is to kind of start to think through, okay, what makes working with data so hard in the first place? And it could be things like setting up rules for deduplication. It could be mapping big systems. It could be cleaning data is tricky. It could be matching and merging and figuring out how things link together. It's not always obvious. These are just some of the ways of why there is the need to bring this co-pilot experience in to the day-to-day. So I'd say this is what we're all here to see. So let me switch over and I'll start sharing a different screen. And do me a favor, Henri, can you tell me if you can see the Chrome? You should be able to see the browser.
I can, yes, looks very good.
Excellent. So let me take you through a use case where we're starting out with an empty account of CluedIn. And this is the system, the web interface that you use to be able to upload and work and steward data. And in this particular case, I'm going to start out by uploading some data to the platform. And in this case, I'm going to start with uploading a couple of files that when you look at it, you would kind of say yourself, there's nothing in the file names themselves that are helping me understand what this data is about. We have a file called export.csv, and we have something called s underscore with some type of date. So we're going to upload this to CluedIn's staging environment in a folder called data. We can see that our files have been uploaded. They should also be loaded in a moment. There we go. So we can start to go and look at them. So I guess one of the first things to ask is, okay, what are we dealing with here in the data? And to the true nature of CluedIn's agility, one of the kind of uniquenesses is that we can onboard the data in any order that we want, and CluedIn will always produce the same result. And this is really nice for that agility and flexibility where you don't have to onboard it in a certain form or order to be able to have it all fit together. So let's take this export file first. And as I open this, I get a preview of what data we have here. And it looks like we've got IDs, first names, genders, job titles, a reports to link, and things like this. So one of the first things that I think could save a lot of time is if I launched into my AI assistant. So in this case, what we're going to do, I'll just pull my screen down here. My co-pilot is being very friendly, and this is one thing that Henri and I agree on, is you should always be friendly to your co-pilot. Nice to meet you. And so there's this nice kind of chat experience that you get. And so, but if I was to say something like, hey, tell me about this data set, right? This is where that dance between the Orchestrator and the Azure OpenAI happens, and it realizes, oh, you're actually wanting to do something with CluedIn itself. This is not just a chat that we're having. And what this has brought back is let me have a look. It says, okay, based on the given data, it appears this is an employee record. I would recommend you choose this as your entity type. There are 100 employee records. Yes, that checks out. There are 14 properties. Yes, that also checks out. Let's have a look at what else it says. I would recommend that we set the country and gender as reference data, so lookup fields. For privacy reasons, it's recommending we don't use some of our enrichment services. And as you can, it's even describing all of the columns for this field down here. It's even mentioning there could be a possible hierarchy in the data that we might want to look at. It's recommending some validation rules that we can do. It's even recommending what it suggests as the unique identifiers, and even starting to suggest we could set up some masking rules due to sensitive values. So this is one of those examples where the server has interjected and said, wait, this is a question for CluedIn. I know what to do here. I don't need the large language model to help by itself. We need to work together. And you can, of course, you don't have to be specific about when you're talking to CluedIn and when you're talking about the large language model. So we might say, hey, for the audience, can you translate this to Danish? And this is an example where it says, well, CluedIn doesn't know how to do that, but I know the content that sits above. The large language model can help me out with that. And you can see that in a moment, it's going to come back and it's going to take the context from the server, and then it's going to translate that in Danish. And Henri can double check the purity of the Danish that comes back. We'll just give it a second.
That's a very long text. You know, Tim, Danish is a very hard language also for large language models.
It seems to have done a relatively good job, I would say.
There we go. That looks good.
So let's do something then. Let's close our Copilot, and because it was helping me suggest the mapping, it suggested that we should create a type of employee, which we will do. We'll take that advice. This is going to create a mapping into the CluedIn system. And it's worth mentioning that this Copilot is available whenever I need it. So if I never need to go and check back and say, hey, what did it say about the unique identifiers? It said, hey, the ID is clearly intended to be the primary key. Okay, so when we go and do our mapping and we need to choose our primary keys, which is over here, we can say, okay, let's choose ID. I'm just going to tag this with Henri just so it stands out. And I'm going to click next. And if we also remember, it said, hey, that reports to column, this looks like a hierarchy. This looks like a relationship to the ID column from the reports to. So this is where we can say, that's a good idea. Let's take that reports to, and let's create a semantic link of reports to. We're going to type our employee, and let's put Henri in there again. And what this is doing is we're going to be building a self-linking reference. So we have, like, you know, Henri reports to Torsten, Torsten reports to Satya. So we've got this internal structure that's in the data. So let's go ahead and push that data into the platform. And in a couple of moments, great, my records have been processed. Okay, so if we head over to our search, we should start to see our records trickling in. And let's go take a look at one of our employee records. So this is the single view of a record that we're loading up right now. And we're just going to go to our properties. And you can see we've got our metadata on here. Now, I would say there's a couple of things here that are pretty bad. First of all, I don't have any validation. I don't have any business rules. And there's some pretty sensitive things that are happening here. I've got account numbers, I've got genders, I've got emails, I've got phone numbers, I've got passports. To be honest, I've even got a passport that doesn't even look like a passport format in the first place. Did that pick that up? Let's just have a look. So what did it say? It said, the passport does not represent a valid looking passport in regards to international standards. So it's picking up all these things. But what I can do is I can have a look at my records, and I can also use my Copilot to start sharing this across the business. So if we head over to the export targets in CluedIn, we've got a SQL Server database set up here, and this is what our BI team uses for all of their reports. We have a mechanism for sharing data called streams. This is a place where we can say, hey, I'd like to share our employee data to the BI team. Here's the place, here's the properties I want to share. So in essence, if I wanted to, I could go find my employee records, these guys here, open up my Copilot and say, okay, can you share the employee data with the BI team? And this is another example where I don't want to chat. Well, maybe I do. Maybe I want it to come back and give me options, but actually I can tell you my intent is, no, can you just share the data? And so it's saying I've shared the employee records to the SQL Server database, have activated the stream. So let's go and look at our streams and refresh. And amazing. A couple of seconds ago, I have a share that's been built. It has set up the filter for me. It has also targeted this towards a database called employees, and it's also targeted my SQL Server database, okay? Now, let's be honest, that saves a couple of minutes. Let's do something a little bit trickier. Let's go back to our employee data that we had. And what do we want to do? Let's, well, in the spirit of being nice to our Copilot, I'm going to thank it. So thanks for doing that. Let's do something instead. Let's say create me all the validation rules for the employee data and tag records that don't comply with an appropriate tag name. So basically, hey, introspect the data and go and find what validation rules to apply, and let's go and create that. So while that's working, let me go over to the rules. We don't have any rules yet, but let's see what it does. Okay. It's suggesting it's suggesting some rules and tag records that don't comply with an appropriate, okay, let's try that again. Maybe I should yell at it. Let's just try that. Okay, that's better. I've created 21 golden records. So let's just refresh our page and, oh man, that is nice. That is so nice. So this has gone through and started creating me business rules for checking if an email is private or work related. It's checking if a passport's in a valid format, all of these rules that it listed. And the fact is that this engine knows what a regular expression looks like for a passport. It knows what it looks like for international phone numbers, and it's building these rules up for me. So you can see how that could literally save hours and hours of work to try and figure out what types of rules of validation, what types of rules of transformation, without really needing to be so prescriptive on what we want it to do. Let's do 2 more demos. What do we have time for? Okay, let's do this. Let's go back to our employee data, and it looked like in the records there was a hierarchy of management. So if we head to our graph view for someone like Valley, it says that Valley reports to these 2 people. So Nico etc. So let's do this. Let's say, I won't thank the Copilot this time, but let's go create me a hierarchy out of this data. So it obviously knows I'm talking about the context of employees still. Sometimes I might need to be very specific on, no, I mean this particular data, but of course it understands we're working in the context of employees. Okay, so I've created a hierarchy based off the reports to relationship. So let's go over and take a look at that. So a few seconds ago, it's created a hierarchy, and beautiful. I now have a visual hierarchy built off my data because it's detected that there's that reports to management line within the data. Let's finish with one more demo. Let's go back to that last data set, and in the chat, feel free to let me know if you recognize what data I'm looking at right now. There'll be a special prize, I guess, for anyone that can guess what table this is or what system this is from. So often we're pulling in data from multiple different systems. And this is one of those cases where it's hard for me to know what is the STRAS, what is ORT, what is CluedIn. So very similar to the other, I can say, please describe this data, okay? And I'll be like, I can say, hey, tell me about this data, or please describe it, doesn't really matter. But what I'm asking is, you've got to help me. Like, what is this data I'm dealing with? And let's see what it says. This looks like the K&A table from SAP for the general data in Customer Master. I would recommend that region and country are reference data. We can enrich it with Dun & Bradstreet and Open Corporates. It doesn't have any immediate recommendations around data quality, but you can see it's also translating all of these column names. CluedIn is customer number, land 1 is country, a 2-digit ISO code. So obviously this is completely aware of how we can accelerate the onboarding of data that's hard for us to understand as well. So I think let's, no, I don't want to do that. Let's just go here. Let's just start up a news chat session. I'm just gonna, let's just thank our Copilot for what it did today. So I'm gonna stop sharing my screen. And with the last few minutes, let me grab one of the questions that we have here, Henri. And maybe I might need you to help answer one of these questions, Henri. Just let me have a look.
Absolutely, Tim.
All right, so this first one is on customer data. Can this deal, and how does this handle customer data? And Henri, why don't you touch us off with a little bit of reiteration of the privacy pieces, and then I can, I guess, touch on CluedIn specifically.
Yeah, absolutely. So with Azure OpenAI, the foundation underneath that provides these large language models that make this possible, you are able to, in your own Azure subscription, deploy an Azure OpenAI instance, just like you deploy any other Azure resource. And that also means that the data you send to that Azure OpenAI resource stays inside of your subscription. So it's the same as if you had a database, or if you're working with traditional machine learning models in Azure. There's essentially no big difference between the way that Azure OpenAI handles specific data to how other Azure services do. There are small caveats around abuse detection, filtering, etc., that we're not going to get into in detail, but you can look those up in the documentation if you're interested. Exactly.
And so just touching on that, it doesn't really matter what data that we have in CluedIn. It will all, none of it's persisted that goes off to the large language model. OpenAI has this kind of concept of a rolling window of tokens, in that after the, depending on what model you're using, that might be 4,000 tokens or 8,000 or 32,000. It essentially forgets everything after that sliding window. And that's just for that session, right? So nothing's actually persisted from CluedIn Azure OpenAI. There is another question, can we get the Copilot to show data catalogs and metadata information? 100%. just like in this, the AI assistant knew when do I talk to CluedIn to do something. You can, of course, say, right, well, we also need it to talk off to the Purview catalog to say, hey, show me the lineage of where this data came from. And the experiences, I think, will get better over time with that. And you can imagine when you're going cross-application, it makes it a little bit complex that you have to start bringing in potentially visual lineage from other places. This was a discussion Henri and I were just having before of, you know, making the Copilot very aesthetically visual, in that instead of just rendering text, it should be rendering HTML, it should be rendering pictures, it should be rendering iframes to show lineage from places like Purview and catalogs and things like this. But essentially, catalogs are a good example of something this can be used for. I think with the last closing moments, you know, the direction that we're going here at CluedIn is that this AI assistant is basically everywhere. So, you know, it's a plug-in to your Microsoft 365 Copilot, it's a plug-in to your Teams Copilot, it could be a plug-in to your Windows 11 Copilot as well. The idea there being, when it's obvious enough to the CluedIn plugin that you're asking it for a particular thing, it knows to hand it off and say, I can go do that work, I know how to answer that question. And so hopefully that was a good show for everybody. Hopefully you get an idea of the value of AI assistants in the data management space. And thank you for all attending. All slides will be